Hello everyone, today I will solve LeetCode question making a large island. In this question we are given n by n binary matrix, that is the matrix will have only zeros and ones, and we are allowed to flip at most 0 to 1. So we might choose to not flip at all, or we can choose 1 0 cell to be 1. And as a result, we need to return the size of the largest island in grid after making this flip. So basically, there can potentially be multiple solutions. We need to decide on the ideal cell that needs to be flipped to get the largest size of the connected island. All right. So to better understand this, let's look at the first example. So in the first example, the grid is 2 by 2, and it's like 1 0 0 1. So we can say that here there are two islands represented by ones, and their sizes are 1 and 1. So here there are two zero values. So in this example, it doesn't really matter which zero we are flipping, because in any case, even if we connect by this cell or this cell, we'll be able to connect these two cells, and at the end we will have result 3. It's not 2 and 3 because we flip one of these to be 1. So at the end we will have an island of size 3. In the second example, similarly, we have a 2 by 2 island. Values are 1, 1, 1, and 0. Here we have an island of size 3, and there is only one bit to flip, so we can make this 1, and at the end we will have a single island of size 4. Let's try to understand a larger example, 4 by 4. In this 4 by 4 matrix, this is an island, and this is another island, and also we have this island. So here there can be multiple scenarios where we merge islands. For instance, so let's first determine the sizes of islands. We have this island of size 3, this island has size 1, and this island has size 4. So if we flip this cell, then we will be merging 3 and 1. Or we can merge like this, and we will get 1 plus 4. But we can also do this and merge 3 and 4. So in this example, there is no scenario where we can change a single cell and connect all 3 islands. So we have to choose 2 islands, and it makes sense to choose 2 largest islands that are 3 and 4. And also there will be another one, the cell that we flipped. So at the end we can merge these things and get a result of 8. And for this one, this will be the resulting large island. Actually, in the code, we will not use a very advanced algorithm. It's only like implementing the solution that I just used for calculating the solution on this 2 example programmatically. So let's think about the steps that I just applied here on this example to get the result. I first determined islands and their sizes, and secondly check 0 cells and their neighbors. So in the code we can basically, after determining all the islands and their sizes, we can iterate on all these 0 cells, and at each 0 cell we can check the neighbors and their sizes, and basically sum these numbers and compare to find the largest island that we can create. I think the reason this question has a hard tag is that it's not because it's using a very complicated algorithm, but implementation is a bit longer than usual. It's around 30 lines, and yeah, that's why I think this question is considered a hard question. Alright, let's code this solution. First, like I mentioned, we need to calculate each of the island sizes. For this, I will use a dictionary to keep all island sizes. And key here will be the island color, and the value will be the size. By color, I mean that we will basically iterate over each of these islands and mark them with a different color for each of these islands. Alright, I will use n, so this will simplify implementation. And island color will start from 2. So here I will start coloring each of these islands. I will visit all the cells and look for islands and start coloring them starting from 2. And the reason is grid already has zeros and ones, and we will directly make changes on the given input grid. That's why we are starting from 2, and we will basically iterate over this grid using I and j as loop variables. And if grid ij is 1, it means that now we are visiting an island, and at this point we should be able to do two things. First, coloring the island with island color, also calculating the size of the island. I will achieve these two tasks using a DFS function. I will define an inner DFS function. It will take I, j, and color as parameters, and ij is the location where we start on the grid, and color is the color that we will use to color this island. I'm gonna first check if I and j are in the range. If not, I and or not for parameter j, or grid ij is not 1. In this case, we can directly return 0 because the first two checks are to verify that we are in the grid, and the last one is we are at a location where the value is 1, that is, we are visiting an island. Otherwise, we can directly return 0 because this is returning, this returns the island size. Alright, so I will color this particular location. Grid ij is now color. And now how do we visit all the other cells in this island? We will basically make recursive calls at the 4 neighboring locations, and this is how we visit all the cells in the island. So I'm gonna do like return. Right, since we already visited ij, we have a 1 because of this, because we already visited this cell, we know that it exists, we already colored it. This is why we have this 1. And for others, I'll basically do for DFS calls. So DFS ij, and we will do this for all 4 neighboring locations, and it will look like I minus 1 j I. Of course we need color parameter as well here. We will color it with the same color. I minus 1 j I j minus 1 I j plus 1 I plus 1 j. So these are all the neighboring locations, and we are making recursive calls to this DFS function with the same color. This will color all the cells in this island, as well as each of these recursive calls will return the visited size, and the sum of these will give us the whole size of this island. All right, now here in this iteration we can get the island size like DFS I, j, and island color. This gives us the whole size, and I will use this to populate island sizes, island color with size. Now I also need to increase island color by 1, because so for the first island we colored it with color ID 2, for the next one we will use 3, and so on. Now we populated island sizes. We know all the islands and their sizes, and now we need to handle two edge cases. The first one is if not island sizes. So this means that we already did the iteration above and we didn't populate it. It means that there were no islands, therefore all the grid was filled with zeros. In this case the result will be 1, because we can flip any of these zeros and make it 1, and at the end result will be 1. The other cases, the whole grid is filled with 1s. In this case the result will be n times n, because the whole grid is a single island, its size is n times n, and this is the maximum result we can get. So we can, and there is no zeros, we can't fill up anything. I will check this like if length of island sizes is 1, if there's only one island, and also island sizes 2, which is the first ID, the color ID that we used for the first island. If the size that this returns is n times n, then we can return n times n. So the first one is no islands, and the second check is for single island, and it covers the whole grid. Alright, now that we handled these two edge cases, now we need to iterate on the grid, find the cells with zeros that we can potentially flip, and determine all the neighboring colors for these cells, then sum the island sizes that are represented by these colors, and calculate the total size of an island when we flip the zero that connects all these colors into a single island. And we will do this for all the locations that currently have value 0, and then find the maximum island size. I will use results for keeping the overall result. Now I will iterate on the grid similar to what we just did, for E in range n, for j in range n, and if grid ij is 0, then we need to find neighbor colors. Here I will build neighbor colors as a set, because if I here use a list, it is possible that one cell might have the same color as its neighbor at multiple neighboring locations. In that case, there's a possibility that we can count the same neighbor twice and count its size twice. So that's why it's a good idea to create neighbor colors as a set here. I will iterate here like for xy in all four directions. It looks like -1, 0, 0, -1, 0, 1, 1, 0. For each of these xy, we will basically add these to I and j, and I will first check if we are still in the grid. I'll check like if 0 smaller or equal I plus x smaller than n, and do the same for j plus y, and also grid I plus x and j plus y has to be something other than 0. So it has to be some other valid color, 2 or greater than 2. If this is the case, then we will get the grid value here, I plus x, j plus y. So here I iterate on all four directions, and if that new location is valid and that cell has a non-zero value, then we will get that value. We will get that color ID, and this represents the neighbor colors. Now we need to find the total size that we can reach by flipping the 0 at location ij. We will do this in this variable total 1 plus, so the 1 here is the cell that we flipped. It flipped from 0 to 1, that's why we are counting it as 1. And now we need to calculate the sum of neighboring island sizes. For color, in neighbor colors, iterating on the neighboring colors, and I will get the island size for a given color like this. So this will basically iterate on all the colors, get the island size for that color and sum all of them, as well as we will add the 1 that is at the center that connects all of these islands into a single island. This is the total size that we can get by flipping the 0 cell from 0 to 1 at location ij. And now we can make this our result if it's greater than the current result. Alright, now we can return the result. This is all the implementation actually. So what we do here, we have island sizes as dictionary. I define this DFS function which uses ij and color as parameters. This function first checks if ij is a valid location in the grid, and if it's so, then we will make sure that we are looking at a valid location that has value 1. If it's not, then we can return 0. So this function returns the island size, as well as a side effect, it will color the location ij with the given color. This handles only one location ij. For the rest of them, we need to make 4 more recursive DFS calls with all the neighboring locations with the same color, and all of them will return the sizes that they colored, and we will sum everything, as well as we will add the one that we have colored in this exact DFS call, and this sum will give us the total size of the island. Now that we have DFS, then we can basically iterate on the grid. If the grid ij has a value 1, then we can call DFS with ij island color. This will both color this island as well as return its size, and this will help us populate island sizes dictionary with this size and color, and we will increase the color. So colors go like 2, 3, 4, so on. And coloring is important because we make sure that we exactly know the size of an island given a color. Here I handle two edge cases. There are no islands in the grid, or the whole grid has a single island that covers the whole grid. After handling them, we just need to iterate on the grid, and for each zero cell we will get a set of neighboring colors and sum the sizes to find the total size that we can generate by connecting these islands. Of course, we will not forget the flipped zero that connects everything. This gives us the result for one merged island, and we will just max this with our overall result variable to find the result. Let's talk about the time and space complexity. Starting from this iteration, we are doing an n-square iteration over the grid, and for each cell we are basically calling the DFS function. So the DFS function will start coloring each of these islands, but DFS can at most color all the islands in the grid. Because of that, the time complexity will be n-squared. And then we have this iteration. It's an n-square iteration again over the grid, and it will perform some constant time operation, because here neighbor colors looks at only 4 directions, and then we will sum this constant number of values here. So this iteration will overall have n-square time complexity, and overall we will have a time complexity of n-square. For space complexity, for coloring, actually we are using the given input grid. It's not exactly auxiliary space. We are modifying the given input. The auxiliary space that we are using here is island sizes dictionary that we use here. And in the worst case, we might have a pattern like this. So if we imagine a pattern like this, then the grid size is n-square, and we will have n-square divided by too many islands, and each of these islands will be colored with a different color. So in terms of big O complexity, this will have again O n-square time space complexity for these island sizes. Alright, so overall we will have for time and space complexity O n-square. And yeah, that's all for this question. Thank you for watching this, and I appreciate any questions and comments and likes. Yeah, thanks.